Hello and welcome to Trash into Treasures podcast series on circular and resource-wise practices and how we can make decisions, sustainable decisions in our everyday life. My name is Ann-Christine Richkoff. I'm coming from Click Innovation and I will be your host during these episodes. And today we turn our attention to electric vehicle batteries, especially what happens to them after their first life on the road. We are exploring how second life batteries are giving EV batteries a new purpose. What does this mean in practice? How safe and cost effective these systems are and how they might contribute to a more sustainable energy future. I'm joined today with two experts from Norway, Aksel Junge Klemsdal from STOR Ltd and Jacob Hadler-Jacobsen from SINTEF. Welcome. It's very great to have you here today.
Thank you.
So before we dive in, let's start a very quick round of introduction. Could Aksel, actually you start? Tell a little bit about yourself and why batteries are so interested and why repurposing them are important for our future.
I'm Aksel, and I work at STOR, who's actually a company who works with repurposing EV batteries for energy storage systems. Batteries are very interesting because we live now in an age where there's a lot of renewable energy. It's a problem how to store this renewable energy because the sun is not always shining, the wind is not always blowing. So batteries are very interesting now because you can store energy and can give it out at any time of day it's actually needed.
Okay, very interesting. What about you, Jacob? You're coming from research institutions. So what kind of research you are carried out in the field of batteries and why?
So I've been doing, a bit different things when it comes to batteries. I started with my PhD, where I looked at the theoretical limitations for batteries. So that means how good can we get the batteries before we start hitting the theoretical limitations when it's not possible to make them better anymore. So I spent some years doing that, and that was very interesting. And then I went over to work in a startup with trying to make batteries as profitable as possible for the industries. And then, like Aksel said, we tried to calculate how can you make as much profit as possible in the batteries by helping them or helping renewables like solar and big factories with peak shaving, as it's called, and helping the electricity grid. So varied things there. But the last year I've been working at SINTEF back to research. And then it's, degradation of batteries, reuse of batteries, and also like future battery technology and lots of different things there.
Okay, that will be, we will have a very interesting discussion because you have the sort of very, very profound experience on batteries and also understanding on what we need in the future. But let's begin with the basics. What EV batteries exactly are and what do we mean when we talk about second life of batteries? Can you tell with the layman's words?
So EV batteries, that's electric vehicle batteries. And it could be both buses, cars, bikes, I guess as well, but that's not so common with motorbikes at least. Quite simple electric vehicle batteries. They used to be lead acid type, but that is long ago. The reason we're seeing the revolution of electrical vehicles now is due to the lithium-ion battery. And those are the batteries we're going to focus on now.
And second life batteries, that refers to the use of the batteries after its first life in an electric vehicle. The reason we want to do that is that typically an electric vehicle have quite strong requirements for the battery. It needs to work if it's cold outside. Typically, user want to charge his car very fast, but after its first life in a vehicle, it will still be more energy left in the battery and more use, and that's where the second life comes in.
So I would like to come back a little bit of the second life. So how is this reuse done in practice? Can anybody dismantle the batteries out of the vehicles and repurpose them, or is it strictly professional type of action? Or
no, I don't think anyone should do it. You need to know a couple of things. I guess you can split it into two ways of doing it. One way would be to just use the whole battery pack, sort of as it is in the vehicle, just take that out, and that's what we do at EcoStore. Another way would be to take out the battery pack and then dismantle it and take the modules out or the cells, and then you can put it into a new package. So we at EcoStore do the whole pack, and one of the advantages there is that first of all, a bit like you're saying, the moment you kind of dismantle it, you take it apart from the original intention. So when you use the whole pack, you can kind of use a bit of the advantage from the original manufacturer, because they already make the system with safety stuff and so on. So that's perhaps the main advantage there.
So what about the safety issues? Because battery systems are known to be quite sensitive in terms of safety. People are afraid of fires and so forth. So if we are giving a second life to the batteries, is there any safety concerns, or is it as safe to use them as the new ones? Or can you tell any risks and how to overcome them?
Of course, a battery will degrade over time, and you might say that the more degraded it is, the less safe it is. But at the same time, a big part of how to make a battery safe is how you manage it. And EV batteries, you have what we call a battery management system that constantly overlooks cell temperatures, cell voltages, and use this to kind of monitor that it's in a safe state. And so one thing you might say is whether or not a bad quality new battery is less safe than a good quality old battery. But it's definitely something to consider when it's old. One question that might be a bit difficult to answer is that once it's second life, it might be not so easy to know who's responsible. Is it the original manufacturer? Maybe you don't have all the information that they had when they originally made it. So you have to do a risk assessment and find out where are the risks, where do we need to put work in order to ensure it's safe.
But that's something what has to be carried out by someone who really have the professional expertise. So laymen or citizens can't do that by themselves.
No.
To analyze whether.
No, I wouldn't recommend that.
Is there any disbeliefs or concerns which are not true among the customers concerning of these EV batteries and especially repurposed batteries?
So I think one belief which might still be a bit common is that electric vehicles they present a bigger fire safety risk, while actually it is more common that internal combustion engines catch fire, or gasoline-powered vehicles catch fire. So something like 10 times more common that the petrol-based vehicles catch fire compared to the electric vehicles catch fire. But you do hear a lot more about it when it's the electric vehicles which catch fire. And in general, that it's just very rare with these fires these days. That is also maybe a problem with the batteries, that so much has happened technologically. So what might have been a bit true in 2010 is not true at all in 2025. So just keeping that in mind. Another thing which one hears sometimes as a battery researcher, that is that batteries can never help the world in any significant scale because they depend on critical raw materials. And again, like the first generation of batteries were very dependent on cobalt. But today we can make lithium-ion batteries without any cobalt at all. And they don't have quite the same range. So you lose maybe 20% of the energy density of the battery. But the overall energy density in batteries has improved a lot. And you can have, 500 kilometers of range with a big cobalt-free battery. And you can even make the batteries, the sodium-ion batteries, which mentioned previously. But they are the raw materials are incredibly common. So you don't need to cut down any rainforest or do any big environmental damage in order to make them, which I think bodes well for the future with respect to the green impact of wide-scale battery adaptation.
If we go to the economics and we discuss about the price of these second life battery systems and we compared them to the, let's say, new batteries or virgin batteries, so to say, are they actually affordable for consumers or companies, or is this repurposing actually increasing the price? How do you see it?
It does take work to repurpose it, and I think in this business now a lot of people are kind of exploring a bit. So at the moment it might be more expensive to put in the work once you explore, but once you get a good product you can take the price a lot down. And something that we might deal with is that the battery prices of new batteries has gone down a lot the last years. And sometimes we see that it's sort of a delay until the market kind of catches on and realized how cheap the batteries has gotten. But this is something to think of right now, but it's also something to think of the next 10 years. And I think that the battery prices of second life will go a lot down. And it matters also what type of battery chemistry you have. So, I think maybe Jacob knows more about this, but
yes.
I can continue on the...
What happens in the battery chemistry nowadays? What are the newest trends?
So the big trend is the lithium iron phosphate batteries. So it used to be that, let's say, roughly 90% at least, more than 90% even, the batteries have a decrease in cost since the first Tesla Model S hit the roads. And what we've seen is that when the batteries were 10 times as expensive as they are today, the cost of raw materials wasn't really so important for the cost of creating a battery. But now we see that the cost for raw materials is maybe 1/3 of the cost of making the battery. Depends a lot on the type of battery, but that puts a lot of pressure on choosing raw materials which are inexpensive. And I mentioned the nickel and the cobalt. Cobalt is well known for being very critical, and also a lot of human rights concerns with the mining of cobalt, environmental concerns. So what we've seen is that these rare metals, there has been a lot of research and also economic incentives to reduce how much we need them in batteries. And then we have gotten this big shift towards these, I would say, a lot more environmental friendly batteries, which use common materials, which are way less damaging to mine and use. But ironically, when you have inexpensive raw materials to make the battery of, it isn't as valuable to recycle. Because if you have nickel and cobalt, which is worth quite a lot in the battery, the battery has a value just as the raw materials in the battery have a value. And that is something which comes into play then.
That's actually very, very important issue. And my next question is the general concern about the future of available of critical raw materials and scarce raw materials what are needed for the batteries. So is this a solution to have these second life batteries that we can actually reduce the use of critical raw materials, I mean the virgin ones? And does it actually help in the availability issue, because it's not related only on the mining and access to the raw materials, but also all these geopolitical situations might affect a lot nowadays, where you actually have them and actually can you have them?
I think it definitely helps to reuse and recycle batteries. And I think also the geopolitical part of it, it is, the lithium iron phosphate batteries. These are metals which are common over quite a lot of the world compared to cobalt, where roughly half the supplies are in like Congo, which is one country.
Yes.
And you even have sodium ion batteries.
Yes.
So lithium is, not all countries have lithium, and the phosphate deposits are not common over all places. But the sodium ion batteries, which is another emerging trend, which is every country in the world more or less has the materials needed to make it, which gives a geopolitical resilience. But I think this reusing, and especially the batteries with nickel and cobalt, reusing, recycling, that will put less pressure on the mining. Even though if everybody in the world, like the electrification is quite small so far.
Yeah.
So the demand, even if we recycle everything, just the need for new batteries is enormous.
Absolutely. And do we actually have the critical materials enough if this electrification starts to increase?
So I think if people want to have the longest range on their electrical vehicles, then I think one will see the prices for cobalt and the nickel increasing a lot.
Yeah.
But then less people will afford it.
Yes.
And when it comes to sodium ion batteries or these lithium iron phosphate batteries, there should be more than enough raw materials for the whole world to go electric, is my impression of things at least.
Okay.
But I guess, and that's sort of one of the main things with repurposing the batteries, is when you take the calculation of, let's say in 2050 or 2030, the majority of EVs or of cars and are electric. So if you can do something to increase the lifetime of that battery, the environmental footprint will be a lot smaller. And when it's such a huge kind of quantity, it can make a huge difference.
So actually the repurposing of the battery and recycling of the critical raw materials from the battery, they are totally different things. Because when you repurpose, you don't actually take out, or do you, some critical materials?
I mean, you extend the use of it.
Yes,
yeah.
You extend the use of it. But in the end of the day, when you can't anymore extend the life, then you should actually take out all the valuables and reuse them. And
that's the recycling part.
Yes.
That will be the end destination. But if you can use it longer, because also when you recycle, you won't get everything back.
That's true. What are the major barriers today for repurposing, but also for the recycling of these critical materials when it's sensible to recycle them?
I think Aksel mentioned it briefly already, but today it is like we're just started on the big electrification process. And recycling and repurposing, that happens, maybe 5 or maybe 10 years after the battery is made. So I think the recycling and repurposing business is just in the really early stage. And if things haven't scaled up, it is expensive. So I think this, since it is so early in the repurposing and recycling of batteries, one hasn't really gotten the economics of scale. And that makes it, hard to compete with very low cost batteries, which are new from China. So I think the cost is the key problem for seeing more recycling and repurposing. But one hasn't really gotten a lot of batteries on the market for selling used batteries yet. That market is very
We know right now how many cars are on the road. So we know it will be a huge increase in 10 years because the sale has increased. And I think also one thing is scale, but another thing that makes it a bit difficult to repurpose is that the technology has been moving so fast. So that means that for each case, you kind of need to do more work. But usually with technology, it kind of you realize what is best, and more kind of goes together to the same point. And also the battery management system is getting better. And another thing that we haven't mentioned is actually that the new EU regulation that also encourage this. And it's the battery passport and these kind of things that would make it a lot easier for us to repurpose it. So what we're working now is kind of the start and the most difficult part, and it will just get easier and easier.
Yeah, that was actually my next question was concerning of the regulation and legislation, which might support or might hinder, because sometimes they do both, depending on the legislation. But I mean, in the sense of governments and policymakers, whether they are in the national or EU level, is there something what they could do to support this shift to repurpose and reuse things?
I think one thing, as far as I know, there's not too much incentives or support for people to choose second life as opposed to first life. But if we do the calculation, we know the life cycle environmental benefits are better if you use it as second life. So that's one thing you could do. You could help and make people have some economic benefit of using it second life. Yeah, the other thing is this EU regulations that we talked about. And I think the new EU regulations may kind of prioritize recycle as opposed to repurposing.
Yes.
So that's one, at least for these NMC batteries that Jacob talked about. So that can push in another direction, but at the same time, a lot of there would also be helpful, such as having this information more freely of the battery manufacturer and the batteries and the battery passport and so on.
I think that Norway is one of the front runners when it comes to the electric vehicles and also battery research and battery activities in a commercial way. So does Norway actually differ from other European countries or Scandinavian countries in the sense?
I think the main thing behind Norway's success with electric vehicles is the profitability of buying electric vehicles. So gasoline cars are very expensive. Electric ones are cheaper, and then people buy what is cheapest.
Okay.
And I think, especially after trying to make a startup in batteries work, people like the environmental benefits, but at the end of the day, it is what is the most cost efficient, saves you the most money, what makes the most profit. So I think the way I see it, to make recycling and repurposing as economically viable as possible.
Yes.
That is, a very efficient way of making it happen to a larger degree. But then the big question is how to do this, and that costs a lot as well.
Yeah.
And then it is, we really want to get renewables going, and then making it as cheap as possible. It is that trade-off sometimes between if it's more expensive to recycle compared to buying a new, and so on. So I think there's a lot of, without going too much in detail on this, but hard trade-offs, but also really important to be aware of them.
Another point that we haven't talked so much about with the regulations, I think, is regarding the battery room. That also we found a bit by experience also in this TREASoURcE project, because batteries are so new, kind of also in Norway to use in buildings and the EU. There aren't that many regulations in place for well, what do you need for a battery room and how do you do this? So while it might cost a certain amount to just buy the battery system itself, it might also be more expensive to just fix a place in the building for using it. And because there's not regulations in place, typically you might need to hire someone who has to do kind of a specific
maintenance, maybe.
Yeah, or the first part where they kind of go to the building and see, okay, what do we need to do here, and so on. So that's something if and this usually comes with time, of course, but that's something that could help, that you have a clear regulation of how a battery room should be. And maybe when you make a new building, that's something you usually have in a new building, because we know in the future it's very likely that batteries will be part of
infrastructure.
Yeah.
And I think that is a very good point Aksel has there. And that's my impression as well. People often want to buy batteries. You have the price for the battery, but then it doesn't happen because it's too expensive to install it when you need to hire engineers to do bespoke engineering almost to use the battery. Because for each and every case, you need to do these safety considerations, other considerations. One hasn't really gotten the how to do it, isn't really well regulated. It isn't well known. And then it becomes so much more expensive. So I think solar panels is a bit ahead there. But if it becomes as easy to have battery rooms and know how to install them as we see people can get solar panels on their roofs, then I think we'll see a lot more of this. Even though there's still some, easy, or it could be easier with solar panels as well. And there are safety issues there as well, and that is a whole different story.
I think that we go now to these practical applications for the repurposed batteries. You have been discussed about buildings and solar panels, but can you actually elaborate a little bit that where these repurposed batteries actually can be used and how?
I mean, solar panels is support to that is an excellent way of using it. I mean, we typically hear people want to do arbitrage, like charge the batteries when electricity is cheap and then use it when it's expensive. But that might not be the best use of the batteries, because that would mean that you use it every day. I mean, a certain battery has only a certain amount of cycles in them. So you should also consider when to use it to extend the lifetime. So one way is to do frequency services to help the grid, something you can actually get paid a lot for. That's if the frequency goes down, you come in with a battery and help put it up. And this is something you have to basically talk to the grid and get approved for this. Another thing, which I think Jacob mentioned, was peak shaving. And it depends a bit, I'm sure, from country to country, and but at least in Norway, on bigger customers, a huge part of the electricity bill is based on the biggest peak you had throughout the month. Yeah. And this is something the battery is really good at supporting, where it just monitors, and once you go over a certain amount, it comes in and supports.
So it balances a little bit this energy consumption and makes it more even.
Yeah.
I think also with the frequency services and the batteries, which, you might not want to use them all the time. So somewhat recently, there was this huge blackout in Spain. And I think that is an example of what happens if you do not have enough batteries or power plants designed to just helping the grids stay stable. So you don't think about it normally, because typically you don't have blackouts. Yeah. But if, the more renewable you have, the more different grid services does the electrical grid need. And the batteries have proven to be really good at those kind of things. Now, I shouldn't be too... I don't know too much details about the Spanish blackout, But you could imagine that if they had more batteries to support the grid, they could have kicked in and helped prevent that blackout. Because sometimes you get this cascading effect. It starts falling out one place, and then it will be more demanding for the neighboring places, and they collapse as well. But then if you have batteries which can kick in on a very short notice, that can help it. Even though the batteries don't need to be just knowing that you have the batteries, they might not be activated, maybe only once a year. Typically it is more though, but this rare event, having batteries as a backup, can be really helpful for the grid. And I think also just on a side note on the different types of batteries. So this... like, do you want to help solar panels? Do you want to have frequency services? Do you want to have peak shaving? Do you want to have backup power in case like a hospital might want to have backup power available? So, but what I've seen for batteries is that often it is a mix of these things you want to use the battery to make it as profitable as possible. And it also depends on what kind of battery you have. So if you have some lithium-ion batteries are like tailored for withstanding a lot of cycles, you can cycle them every day without too much degradation. Other batteries, they might be second life batteries. They are already a bit worn. You don't want to use them too often. And then you have different applications which suit those different batteries the best. Ideal case would be that the grid, solar panels, all those stationary battery needs, they are met by different types of batteries. Someone made to stabilize the grid, someone specifically made to help solar power, and so on.
Yeah. But if we think about the buildings, I mean, is there any kind of requirements for the buildings and the repurposed batteries? Like, can you use them in residential house, or are they strictly meant for official buildings or hospitals or industrial buildings? Is there any type of...
I think it depends a lot on the batteries. Like Aksel said, with the second life batteries, you might want to do it a bit larger scale because then safety is even more important. But you also see that Tesla sells the Powerwall, which is specifically made for residential houses.
Yes.
And then you have a Tesla which makes the Megapack, which is made for industrial size consumers. So my impression is that these stationary batteries, they are made for the whole range of applications, from really huge container-sized batteries to batteries which, a tiny battery you might want to have at your cabin to help the solar panel.
Yeah, I think that's true. It's this point, it's sort of... you need to do a certain amount of work to set up a battery system. So if you can make it twice as big in a larger building, as opposed to do two different smaller residential sides, it's more beneficial to have a bigger system. That's the main point, I think. But in theory, you could use it for everything, but it's more difficult.
Okay, what about the storage aspect? So how long is the energy stored typically to the batteries? I mean, if we think about that, there's a big security impact as well, because as we learned from the big blackout in Spain, Portugal, and part of France, if something happens and we have the battery system, so how long would it actually store the energy? So how long this kind of blackout can happen and last?
I'm not an expert on what happened in Spain, but I'm not sure if I think what the battery could have helped in that situation is for it to not be a blackout in the first place. Yeah. Because they would come in and see that the grid is unstable, maybe the frequency is too low, and it helps stabilizing it. But as I said, I'm not sure exactly what happened there. You could also use them as backup for the blackout itself, but I'm not sure if that's the best use of it. Maybe you know. Jacob.
So I talked with someone who worked with the grid, and it is, as you say, Aksel, that batteries help to prevent the blackout. So typically a blackout happens when you have some small fluctuations happening, that suddenly there's a huge increase somewhere because maybe a factory suddenly disconnects, or maybe a power plant suddenly disconnects, and then it is to keep things stable. And that has gotten harder with a lot of renewables, but then batteries can help that. But I think you said, how long can the energy be stored in a battery? And what you see is that batteries store energy really well. So you have this self-discharge. If you have a battery just laying around unused, it will discharge itself a tiny bit. Yeah. But then we're talking like maybe 1 to 3% a month.
Okay.
So even a year, you would have a lot of battery, or a lot of electricity or energy left in your battery. Okay. So I think that concern is quite low. It is more that it is expensive to buy a battery, and that's the main reason you don't have too much of backup power.
Yeah, I was wondering if you meant like how long it could take the whole toll of the whole grid, but maybe you meant this.
Yeah.
But I think as a comparison, you have an electric vehicle's battery. That is, if you live in a flat, it could support your flat for, I would say, a week's time, maybe more, depending a lot on where you live and how much electricity you use. But 50 to 100 kilowatt hours battery, which is a typical electric vehicle range or electric vehicle size of batteries. That is a fair amount of electricity. So I imagine maybe in the future, if you have a blackout, you will just run your house on power from the battery in your electric vehicle. Yeah. That is something which can help. Or you could just have that your electric vehicle is connected to the grid while it's being parked, and then it can help the grid, and you can make some money on just having your battery help the grid, especially now that batteries are starting to get a really long lifetime.
Yeah, can you actually do that you connect your electric vehicle battery to the grid? Or somebody has to do it for you?
Technically, it is possible to have what they call two-way charging. It isn't so widespread yet. That is a bit due to regulations. The grid is something which, technologically, one likes to be really conservative. Yeah. Because if you do too much crazy things with the grid, you really don't want to get blackouts. Yeah. But I think for the Lightning electric pickup truck, they're part of the selling point for that, and they have ads for it, is that they show like, you're some natural disaster, you lose power, this truck can supply your house with electricity for 1 week. I think they use as the number in that ad. And that is not connected to the grid itself, because that's still a regulatory a bit sketchy, but then it is like you have this switch in your house that the house can either it has a special charger so that it can let your house charge the car, or the car can charge your house instead. So you're seeing this being rolled out now, and I'm really excited to see this development going further, but it's still in the early stages.
I want to go back to the financial things and this return of investment. As we have heard, both the repurposing and also using these repurposed batteries, it's some sort of investment what has to be done. So what is the general return of investment, and how we could kind of shorten and minimize this payback time? Any ideas?
Yeah, maybe the focus shouldn't be to reduce the payback time. If that means that your battery lasts 5 instead of 10 or 15 years, it's maybe better to focus on how much in its total lifetime can it save you. Yeah. But there is, like we talked about, frequency services is a very good way to do that. And there you actually, you need to get approved for this. But once you're approved, you basically just get money to be ready to help the grid in case something happens, which means like even if nothing happens, you're still constantly earning money. And that's somewhere where you then get money, and it will also help your battery last longer. Peak shaving is another that we talked about. And we have done one study where we saw for one customer, for example, I think 60% of the electricity bill was based on the highest peak a month. So that's a huge part where you can put in the battery for these times. And this is if you have a building that has very variable amount of energy use or consumption, this can help a lot. And then it's also with solar power, where if you have so much solar power that it exceeds the use of the consumption of the building, then you can basically put this in and get free energy in a way.
So basically, when we are estimating these benefits, it's not only the economics what matters, it's much more systemic and holistic thinking you need to understand that what are the real benefits. Economics is just one part, but then you have to think about the lifetime and
economics is important, of course, but
companies, of course.
But I mean that maybe the focus shouldn't be like how quickly can I get the money back, because you're buying the battery not just for 3 years, you're buying it for 10 to 15 years. So it's not a short-term investment, but a longer-term investment.
I think when working with companies who want to make money on batteries, it is a bit sad maybe, but this 10 years, what happens beyond 10 years is often not considered so much. That things should pay itself back in 10 years. So then it is, as I say, to make people think more than just 10 years. So that might be a bit, with the culture. It is also a lot with this, how financials work, that you have this diskontinueringsrente. They have these different financial kind of laws, which makes it very important to make money and make money fast. But I think one thing which makes help reduce the payback time, that is unfortunately or fortunately high electricity prices. Yes. So in was it 2021, 2022 that the electricity prices were quite high.
Yeah, 22.
And then we were very happy in the company when we tried to show that batteries were profitable, and they become a lot more profitable when the electricity prices doubled for 2022.
Yes.
So that is one way to, if it becomes more acceptable with the varying prices, which are also quite high, then the batteries will be a lot more profitable as well. And the last thing is just to make things as cheap as possible. Because if batteries cost half as much as they did previously, then they pay themselves back twice as fast. So that is what is helping a lot, that the battery costs are going down. And I checked up quickly before this podcast, but it was 20% the battery costs on a pack level was reduced from 2023 to 2024. Yeah. And when you have like the double-digit cost reductions, that is going to help batteries become profitable. So I believe that in the coming years, we will see that even without too much incentives, just the reduced cost of batteries will make payback times become so good that you see private companies starting to invest here, even without any European Union kind of forcing them to do it. But we don't have too much time either. So it's going the right direction, but is it going the right direction fast enough?
That's a good question. Okay, so that brings us to the end of the episode, and we have heard and learned how these Second Life EV batteries can support more stable and circular energy systems, especially in the future. So I really thank you for your very, very nice and insightful discussion on this rather difficult topic. And I also hope that our listeners, our audience, enjoyed this episode, and feel free to share it. And stay tuned, because more of conversations on sustainability and resource-wise solutions will come. Until next time, take care and stay informed.